Hi guys, today we're going to be starting a brand new chapter about quadratic functions, and today we're going to be looking specifically at the quadratic function form called the vertex form. Now, just to make sure we're all on the same page, a quadratic function is a function whose graph looks like a parabola, and so sometimes parabolas will open up like this one, and sometimes they'll open down. And later on, we'll talk about how to tell if your parabola will open up or if it will open down. And there are several different ways you can write the equation of a parabola. But today we're going to be focusing mainly on the vertex form. And the vertex form is this: y equals a times x minus h squared plus k. Now, when it is written in this form, we can tell a couple of different things. First of all, when it's written in this form, you won't see the letters A, H, and K. You will see a constant substituted in for the A constant substituted in for the H, and a constant substituted in for the K. And then whenever it's written in this vertex form, you will be able to see a few different features. The first feature you're going to be able to see is the vertex. The vertex is written as H, comma, K. And notice when I write it like this H is like a positive H, and that H in the formula is negative. So whatever you see in the formula, the opposite of it will be your vertex. The other feature you're going to be able to tell is the axis of symmetry. And I'll talk a little bit more about that in a minute, but just for right now, write down this vocabulary word, axis of symmetry. The axis of symmetry is always going to be at the equation. It's a vertical line. It's always going to be at the equation x equals h. Then you can also look at the equation in vertex form, and you can tell whether or not you're going to have what I like to call a happy parabola or a sad parabola. And here's how I remember. If things are going positive in your life, so like if you have a positive A, and by A I mean this A value right here. If that A value is positive, your parabola is going to be happy and it will open up. If that A value is negative, like things are going negative in life, you're probably sad. You're probably making a sad face. So you can tell if your parabola is going to open up or down based on the A value. The A value, last chapter we also talked about as being the vertical stretch or shrink. And that same thing goes in this scenario too. Let's see, what else can we tell? We can also look at a quadratic function, and I can give you information about the domain. Now the domain is all the possible x values. Since a parabola is going to reach forever and ever to the left and forever and ever to the right, the domain for all parabolas, for all quadratic functions, is negative infinity to infinity. And that will be true for all quadratic functions unless you're working on a word problem and they have to restrict the domain to make sense for real life. If you want to know the range, it's going to depend on whether or not your parabola opens up or opens down. So let's say your parabola opens up. If your parabola opens up, then the range is going to be the k value until infinity. If the parabola opens down, then your range is going to be negative infinity until that k value. Okay, so those are some of the key features I can see just from looking at the equation, and we'll be working with those a little bit more later. So here, let me give you an overview of what the examples ask us to do in our notes today, and then we'll start working on them. So example number 1, it's kind of a review from last chapter. You're going to graph using transformations, and then we'll talk about how these transformations relate to the vertex form. Then example 2, we're going to identify key features without having to use a graph. So we don't have to graph all of ours, which is kind of nice. We don't have to graph forever. Example 3 is going to be how to write the equation of a parabola. Example 4 and 5 are how to write the equation of a parabola in vertex form, and then I'll also give you a preview of standard form that you're going to see next class. So let's graph using transformations. All right, so example 1 says describe the transformations of the parent function of f of x, then graph the function. All right, so I'm looking at this and I see plus 2 inside a grouping symbol. So plus 2 inside the grouping symbol means that the parent function is going to shift to the left 2 units. And then that negative is going to be a reflection across the x-axis. I'm going to try to go back and fix that. Reflect across the x-axis. Okay, so then I've got Desmos right here. Here is the graph of x squared. The graph of x squared is right here. It's the parent function. So notice the parent function has a point at 0, 0. And let's see, I wonder if I can pull up the table here. Yeah. It's got a point at 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Now, when I graph the other function, it shifts everything to the left, 2, and then reflects it across the x-axis. So this point that was at 1, 1, it goes to the left, 2, 1, 2, and then gets reflected across the x-axis to be negative 1. It's not really going to that point right there. Negative 1, negative 1, negative 1. The point that was at negative 1, positive 1, shifts to the left 2 units, and then reflects across the x-axis. Okay. The second part B example, I see a minus 1 in parentheses, so that tells me the function is going to shift to the right 1 unit. And then it's going to shift up 2. So, back to my Desmos calculator. X squared is graphed. I want to shift it to the right 1 and then up 2, which means, hold on, let me graph an equation. I forgot what the equation was. Minus 1 squared plus 2. So, y equals x minus 1 squared, and then plus 2. It's going to shift every single point to the right 1 and then up 2. This point right here gets shifted to the right 1 and up 2. Every single point in the parabola gets shifted right 1 and up 2. Now, I said before that my vertex I could find by looking at the equation. So if I look here, the vertex is HK. Well, right here, let me get my blue. If I were to just look at the equation, actually, let me go to this one. If I were to just look at the equation, that value would be my H and that 2 would be my K. So that would tell me that the vertex of my graph should be at positive 1 because you take the opposite of what's in here, 2. And then the vertex, and let's double check my graph. Is the vertex at 1, 2? 1, 2, oh, look, there it is. Vertex is at 1, 2. And then for this one, the vertex would be at, let's see, there is the H value. See, H is right in the parentheses with the X. So X minus whatever that number is, that's your H. So I've got X minus, but it's a positive 2. So I'll take the opposite of that. My H would be negative 2. And K, well, there's nothing out here, so that's the same as saying plus 0. So K would be 0. So negative 2, 0 is the vertex. And just a reminder, let's go check that graph again. Negative x plus 2 squared. Vertex is at negative 2, 0. Now in example 2, I have to look at the equation and determine all of these features without even graphing. So I'm going to go with my vertex form again, and I'm going to say, okay, well, first of all, I know that this parabola has a negative out front. So automatically that tells me that my parabola opens down. So I'm just going to come over here and sketch that because it kind of helps me a little bit. Okay, so my parabola opens down. Check. Next, I need to identify the vertex. Well, I look at this number and take the opposite of it. So I know that my vertex, the opposite of positive 4 is negative 4. And then I take this number as it is, negative 5. So that tells me the vertex of this parabola is negative 4, negative 5. Okay, so I found the vertex. Check. Axis of symmetry. The axis of symmetry is a line that goes straight through the vertex. My drawing isn't great here, so I'll show you on Desmond's in just a minute. But it's a vertical line that goes straight through the vertex, and it's a symmetrical line. So anything that happens on the right side is symmetrical on the left side. And so this axis of symmetry goes straight through the vertex. So it is at the equation x equals, and you take the x value of the vertex. X equals negative 4. And I'll label it over here too. X equals negative 4. Okay, found the axis of symmetry. Minimum or maximum. Now the minimum or maximum will happen at the vertex, but your minimum or your maximum value, those are y values. And so your parabola will only have one or the other. It will have a minimum or a maximum. That would be the highest or the lowest point. Now my parabola, it opens down and it keeps extending down forever and ever. So there's no minimum. But there is a maximum point. It's at the vertex. But I only give the y value. So I would say that negative 5 is my maximum value. So the way that you would say this is you would say there is a maximum of negative 5. There is no minimum, only a maximum. So I found that. All right, domain. I said earlier your domain is always going to be negative infinity to infinity. So I'll say domain, I'll abbreviate D. Domain, negative infinity until infinity. And then range, well, my parabola opens down, so my range will be negative infinity until this y value right there. So the range, parentheses, negative infinity until the y value of negative 5. Close that bracket.